All right, guys, thank you for coming. Miklin, one of our TA, she's gonna basically lead the session today to go over with you the solution to the practice test. She's also going to go over some part of the lectures from yesterday about typecast, which can also help you maybe more about understanding. You can also feel free to shoot out the questions during the session. I'll be here just in case anything I should answer, I'll answer as well. But it's gonna be mainly Miklin leading the session. Okay, Miklin, go ahead.
Okay. Hi guys, my name is Miklin, TA. So we're going to go over this first question. I kind of drew a little bit out to start off, but as we can see, we have 6 points here, but I only draw 4 different objects because as you can see, there's only 4 times where you say new. So when you don't say new, like in 5 and 6, and you're not going to draw a new object. That's when these two are going to reference the same object. So I'm just going to draw P5 and P6. So it says P5 should point to the same object that P2 is pointing to, which is over here. So I'm going to draw P5, and it's going to point to this one because that's where P2 is pointing to. And then I'm going to draw P6, and that's going to point to where P4 is pointing to, which is over here. So there we go. And so this is just like how you draw, how you want to set up, which is like one of the most important parts. So you just want to make sure your drawing is correct, because like if your drawing is wrong, then you're going to get wrong answers. So just make sure.
I think you meant to say P6 over there.
Oh yeah, P6, yep. But yeah, just make sure, like, don't make a mistake like me and do your drawing correctly. But yeah. So now going into it, we have all our assertions here. And so the first one is assert. As you can see, we have like some that say assert same and some that say assert equals. So the first one says assert not same, P1 and P2. So we can kind of think of like assert same. When you have A, B, this like boils down into A equals B. But since this is kind of like equals, like this way, like you could, it also, B equals A means the same thing as A equals B. However, when we're doing assert equals, the order is more important. So A and B, this equals A dot equals B, but it doesn't always necessarily equal B dot equals A. So it just like, you have to be careful about the order for assert equals, but for assert same, it's just like if it's A or B or A, it means the same thing. But yeah, so also we can kind of write this, like, since like this is A equals B and B equals A, we can kind of write this like assert same to be kind of like, or like assert false P1 equals P2. Because as you can see, that since this equals A equals B, you can write it as P1 equals P2. But when you have this, like P1 equals P2, it returns true or false. And depending on whether it's true or false will determine whether this passes or fails. So in the case of assert false passes when this operation here evaluates to false, and it fails if this here evaluates to true. So does that make sense so far, everybody? Any questions? Okay, good. So yeah, so since this is saying assert false, P1 equals P2, we have to ask ourselves, does P1 and P2 have the same reference? So do they point to the same object? So as we can see, P1 and P2 don't point to the same object. So that means that this is going to return false, which means that assert false is going to pass because it's asking, does this assert to false? That makes sense. But we can conversely also write this as an assert true, or we kind of do a different color. So does anyone know how we can kind of write this assert false P1 equals? Like what can I write in here for this to equal that. Yeah? Exactly, yeah. So we can write P1 doesn't equals P2. And you can also write it as not P1 equals P2. So these two mean the same thing. Just duplicate. So yeah, does that make sense? Any questions? Okay, good. So now, similarly for assert same, we have P4 and P6. So that's asking, does P4 and P6 point to the same object? Do they reference the same object? So as you can see, P4 and P6 do point to the same object. So that means this is going to be true. So it's going to pass. So sorry, once again, this is going to be a pass, and this is going to be a pass. And then now we get to assert equals. This is kind of where we have to, the order is important. So this is P3 and P4. So that means that this is going to evaluate to P3 dot equals P4. But then we have to ask ourselves, what type, what class is P3? So P3 is of the class point V2, and point V2 has the overwritten equals methods here, as we can see. So when we look at comparing P4, and P4 is also of the point V2 class as well. So they're of the same class, and when we look at the overwritten equals method here, so they're of the same class, and they have the same x and y. So that means they're the same in terms of the equals method for point V2. So that means that this is going to be true as well. Any questions? Okay. And then now the next one, assert equals P2.
So Mikle, how about you just say a little bit more about which version of the equals method should be called? What should we judge?
So when we're looking at which version of the equals method should be called, you always want to look at the context object, which is P3 in this case. So it's our context object. This is the context object. And you want to look at the dynamic type of the context object. So because the dynamic type determines which version of the method you're going to call. So since the dynamic type of P3 is of V2, so it's V2. So that's why we're calling this one over here and not like the regular one from the object class. So yeah. And yeah, so now going to this one now, question D. So P2 and P5. So that, once again, is going to be P2 dot equals P5. And as we can see, P2 is of class V1, and P5 is of, oh, they're the same thing. So yeah, so they both point to the same reference. And like another thing you can kind of think of that is that when the equals method is not overwritten, so as we can see, like point V1 doesn't have its equals method overwritten, assert equals and assert same mean the same thing, or if the equals method is not overwritten. So you kind of ask yourself, do they point to the same reference? That's what assert equals is saying. But when we looked at like this previous example, since our equals method was overwritten, we have to ask ourselves more than just do they point to the same object. We have to like ask ourselves, you know, how we define it over here. But since in P2, its dynamic type is V1 and V1 doesn't have it overwritten, you just have to ask yourself, are they pointing to the same object? Which they are. So in this case, this one passes as well. And then here we have assert same. So assert same follows like the same rules I was saying over here, but just like the opposite. So when you ask yourself assert same for P1 and P2, it's asking, does P1 and P2 point to the same reference? So as we can see, they don't point to the same reference. P1 points over here, and P2 points over here, so they don't point to the same thing. So that means that this is going to fail. So this is our first one where it fails, and then you can like check the box for it. So now assert equals P1, P2. So I'm just going to write that over here. That's once again P1 dot equals P2. And we can see P1 and P2 are of the same class, but that doesn't really matter. The only thing you really care about when you're writing this is what is the dynamic type of P1, the context object. So in this case, once again, it's a V1, so you have to ask yourself, does P1 and P2 point to the same object since it's not overwritten? And they're not, so this is gonna fail as well. So this is gonna fail. So then we're gonna click this. And then now we have assert not same, P4 and P6. So kind of like a little tip you could say is that sometimes, like you can see in this question, we're gonna have like assert same and assert not same. So when you see two things that are kind of like the opposite of each other, you can kind of, well, you can kind of think one might be wrong and one might be correct. So since this one was correct, then maybe we can think that this one might be wrong. But let's just like prove that. So as you can see, this is saying do P4 assert not same. So that's saying that P4 and P6 shouldn't point to the same object. But as we can see, P4 and P6 do. So that means that this fails. So this is going to be a fail. And then now we have assert not equals P3, P4. So I think so as you can see, it's kind of the same thing here. We have assert equals and assert not equals. So like we can use our critical thinking skills and think one might be wrong and one might be correct. So we can just prove that again because P3 and P4 are of point V2. So that means so the overwritten equals, it doesn't necessarily mean they have to point to the same object. We have to check how do we define our equals method in point V2 since the context object is of P3, which is of class V2. And so here we define they're the same if they have the same x and y, which they do. So that's why these are equal, but this is assert not equals. So it's wrong. So it's wrong. Check this. And assert equals P5 and P6. So I'm just going to maybe make a new page just so I have a bit more space. Paste page. And then I'm just going to maybe erase this so I can focus on the last two now. Or I'll just erase this. So now when we have assert equals P5 and P6, so that's going to be P5 dot equals P6. So once again, we have to look at our context object and see what dynamic type that is to determine which version of the equals method we're going to call. So P5, so context object, its dynamic type is, so you can see P5 points to P2, and well, they point to the same thing, which is a V1. So that means that we're going to be calling the regular equals method from the object class. So that means so even though like P6 is of point V2 here, like we don't care about that. You only care about what is the dynamic type of the context object. So now you have to ask yourself, does point 5 and point 6 point to the same object since we're using the regular object class equals method? And they don't. So that means that they're not equal, which means that assert equals would be wrong. So yeah. And then finally, for the last one, assert equals P6 and P5. So we're just gonna write it like this, P6 dot equals P5. So now we can see that our context object is of class type V2. Its dynamic type is V2. So that means that we're going to be looking at our overwritten equals method. So we need to look at this. Well, first of all, does anyone have any guess whether this is going to be, whether this is going to pass or fail? Fail? Why?
Because it's going to call the overridden version, but their classes are different. So at that point, it will return false.
Exactly, you're right. So even though like P6, you might think like, oh, like, you know, P6 and P5, they both have the same x and y. So, you might think, that should return a pass, but it's actually wrong because before you even, as he was saying, before you even check whether the x and y's are the same, you have to check whether you have to check whether the classes are the same. So as you can see, P6 has class V2, whereas P5 has class V1. So this automatically, this will return false. So you don't even get to check if their x and y's will be the same. So, yeah?
So when it's checking for the class, does it check the dynamic type or does it check the static type for that particular line?
It checks the dynamic type. Yeah, it checks the dynamic type. So it's checking whether the dynamic types are the same.
And remember what we said in the lecture, you shouldn't really compare apple with banana. So apple, banana here, really the actual objects that that's being pointed to, the title of the box.
So yeah, so then this fails as well. So yeah, and that's the first question. Does anyone have any questions about it? Okay, great, amazing. Okay, let's move on to the second. Oh, let me erase the diagram. Oopsies. Okay, so here is the second question. I'm going to draw it out with you guys. So once again, it's very important you draw your diagrams correctly because or else your answer is going to be wrong. But you want to make sure you can draw it pretty fast because you don't got time. You could have like 100 different classes, but just make sure they're correct. You just need balance. Yeah. But anyway, so when you're kind of a bunch of classes like this, like the first thing that you should always look out for is like which class doesn't have an extends. Because whatever class doesn't have an extends means that that's going to be your superclass. As you can see, class C doesn't extend from everything. So that means that it's going to be at the top of our hierarchy. So we have C. And then now we should look like what extends from C so we can continue like building on. So as we can see, B extends from C and D extends from C. So we're just going to draw it out. So we have B over here and then D over here. And now we can ask ourselves, is there anything that extends from B and D? And then we just keep on like growing it as we go. So we can see that A extends from B. So we can first do that. And we can see that F extends from D. Just make this a little bit nicer. Oh. What is this? What's this? D. And then this is F. And then now we have to ask ourselves, like, what extends from A and F? As you can see, nothing else extends from A, so this is going to end over here. And as we can see, though, we have E extends from F. So now we can have E. So that's how we draw our inheritance diagram. So yeah. And then I'm also just going to write every method that's in each of them just so we can kind of reference that for later to help us. So E has DM, F has BM and EM, D has CM, and C has BM. So yeah, so that's how we draw it. And oh, sorry, there we go. So when we look at this, though, as we can see, it's inheritance. But even though, for example, D doesn't have, explicitly BM defined in it, every class, every descendant inherits everything from, like, basically every descendant of everything, every descendant of the superclass inherits the methods in the superclass. So every method here, every class here will have BM you can use in it. So yes, even though like D doesn't have BM defined in it, you can call BM from it because it inherits it. So yeah. And then, so now I know like in your practice test, it kind of splits everything, one line for each question. I'm just gonna do questions that fit on the page and then make a new page when need be. So yeah, so we're gonna look at the first one. So just maybe move this a bit up. So as we can see, we have D, D1 equals new C. So that means we're we're making a new object. But first, we always have to check, first, does it compile? So when we're checking compilation, when we're creating a new object, we have to look, just my highlighter. Have to check, does the expectations, can the expectations of the right-hand side, which is the dynamic type, fulfill the expectations on the left-hand side, which is your static type? So in other words, C should be an ancestor of D, because in order for C to fulfill the expectations...
sorry, Micklin, C should be a descendant
Yeah, sorry, C should be a descendant of D. Because in order for the right-hand side to fulfill the expectations, it should be a descendant, because as you get lower, there's more expectations. So yeah, so as you can see here, I'm gonna highlight D and C. As you can see though, C should be a descendant of D in order for this to compile, but it's not. C is an ancestor of D. So C cannot fulfill the expectations of D, because as you can see, D has CM, but C has BM, so it can't fulfill that expectation. So that's why this won't compile. So this will not compile, and I'm just gonna comment it out so it doesn't confuse people. So now, let me just maybe oh, did I? Oh, yeah. So I'm just going to erase the highlights here so we can do the next question. So now, you can see it's kind of flipped now. So we have C D2 equals new D. So now we have to ask ourselves, once again, can the expectations of the right-hand side, which is the dynamic type, fulfill the expectations on the left-hand side, which is the static type? So C is here, D is here. And once again, since D is a descendant of C, the static type, then that means this is compilable, because that means now D can fulfill C's expectations. So.
And Micklin, maybe you can remove the highlight for line number 1 so we don't get confused of the color.
There we go. There we go. So now I'm just going to draw new, and since we have like the new keyword, that means we're going to have to draw a new object. So this is dynamic type D. D2 points to this, or let me just remove this a little bit here. And its static type is C. So yeah, any questions so far? Okay, amazing. So now we're moving on to line 3, which is D2.bm. So whenever we're looking at method calls, we first have to make sure that it compiles. So to check whether a method call compiles, you have to look at the context object static type. So we can see we drew D2 here, and D2 static type is C. So, and then we have to check, is this method being called BM defined or inherited from C? It's static type. So as we can see, if we go to class C here, we see that BM is indeed defined here, so that means that we can call it. And then when we look at which version is called, that's when we look at the dynamic type. So since the dynamic type is of type D, we look here, but we see that BM isn't overridden in here, so then we have to look at the closest ancestor that has BM defined. So then we have to go up to its ancestor, which is C, and we see that it's defined here, so we're going to use C's version of BM. So that means that this now is going to print, so I'll just do a check. It's going to print C.bm. I'm pretty sure that's how it prints it out. But yeah, here, oh yeah, C.bm. So it uses C's class of the BM method call. So yeah, that makes sense? Any questions? Okay, great. Okay, now we're doing line 4. So this is DE1 equals new E. So as we can see, we have the new keyword. Before we even draw anything, to make sure it compiles. So we have to look at its dynamic and static types. So I'm just gonna, maybe I'll create a new page. Paste page. So now we have to ask ourselves, once again, can the expectations of the dynamic type on the right-hand side fulfill the expectations of the static type on the left-hand side? So basically we're asking, can E, the class E, fulfill the expectations of D, which means, is E a descendant of D? Oh, sorry, there's a picture. So it asks, is E a descendant of D? So as we can see, here is D, and here is E. And E is indeed a descendant, so that means this will compile. So I'm just gonna draw it over here, and then this is, so we put the dynamic type in the box, and then we write, I'll just do E1, and its static type is D. So yeah, there's that. And then now, for the next line, it's a little bit more tricky, variable reassignment. So to first check whether this compiles, we have to check the static type of both variables. So it's kind of like how we look at the static type when we're making a new variable. You have to ask yourself, can the static type on the right-hand side fulfill the expectations of the static type on the left-hand side? So I'll make a new page for this as well. So, paste page. So this is going to be, so in other words, the static type of E1 should be a descendant of the static type of D2. So we don't care about the dynamic type, EED, we don't care. For compilation, we're just going to look at static type, which is important. So as we can see, so D2, so if we look in our diagram here, D2 has static type C. So we can highlight that here. And E1 has static type D. So we're going to highlight D here. And as we can see, D is a descendant of C. So it can fulfill the expectations of C, which means that this variable reassignment is going to be compilable. And then, but now when we have to look at the dynamic type, because we're not done yet. We have to now point, so now we say whatever D2 was pointing to, we're going to point to wherever E1 is now pointing to, where E1 is now pointing to. So we kind of draw our little diagram here. So before line 5, wait, what's my, is it not here? Okay. So before line 5 and after line 5, we can look at the static type of D2 and the dynamic type of D2. So once again, static type never changes. So the static type of D2 before and after line 5 will stay the same, which is C. So we're going to write C here. As we can see, before this happened, we can see that D2 pointed to this object and it had dynamic type D. So that means the dynamic type was D before line 5. But now after the assignment, D2 now points to wherever E1 was pointing to. So that means now its dynamic type changes to be whatever dynamic type E1 is. So E1's dynamic type, as we can see, is E. So now its dynamic type changes to be E. So just like a little recap, to make sure it's compilable, make sure static type of left-hand side is an ancestor of static type on right-hand side. And then if it's compilable, then now the dynamic type of the left-hand side becomes the dynamic type of the right-hand side. So, yeah. Yeah, so now we know that this is compilable. So I'll just do a check mark. And then, yeah, so now line 6, now we're doing, so as you can see, we did d2.bm in line 3, and now we're going to do d2.bm again. So, so once again, to make sure whether a method call compiles, we have to check, is bm defined or inherited from its ancestors in its static type? So d2 static type didn't change. So D2.bm compiled before, so it should compile now, since we didn't change the static type, only dynamic type changes. So it's compilable, because as we can see, C has bm defined here. And now knowing to decide which version of bm, it's going to call it look at the dynamic type. So before, the dynamic type was D, so we called this one over here. But now, since our dynamic type is now E, we have to ask ourselves, we're going to continue to go from E, our dynamic type, climbing up to our ancestors until we see the first instance of bm. So we see E, we go to our ancestor, we see bm's now defined here. So now we're calling F's version of bm and no longer C. So this is now going to call F.bm. Does that make sense? Any questions about like why this one called F and the other one called C? Okay, great. Okay. So yeah. So now I'm just going to make a new page. Copy. Now we're going to do line 7. So maybe I'll just move this here. I don't think we need this anymore for here. So as we can see, it's F equals E1, but we don't have a new object. So we don't have a new object, so we're not creating any new objects. So this is just saying now we're going to want to have F point to wherever E1 is pointing to. So this is like what it wants to do, like that. But for it to ask itself, will it compile? Will this compile? So to check where this will compile, we have to check, is the static type of F, or is the static type of F an ancestor of the static type of E1? So in other words, can the static type of E1 fulfill the expectations of the static type of the left-hand side, which is F? So if you look at E1, the static type of E1 is D. So let me just kind of erase this. And, oh. So this. So the static type of E1 is D. So D. And then F, so the static type of F is F. But as we can see here, that D is not a descendant of F, it's an ancestor. So that means that the E1 cannot fulfill the expectations. So basically, class D cannot fulfill the expectations of F since it's its ancestor. And when you go like higher in the inheritance hierarchy, you have less expectations. So since it's an ancestor, not descendant, then it just does not compile because it can't fulfill the expectations. So yeah. So therefore, this will not compile, if that wasn't clear. So yeah, this will not compile, and we can comment this out. And finally, now we have E1.em. So once again, to check whether a method call will compile, we have to ask ourselves, is em defined or inherited from its ancestors from E1 static type? So let's check. So E1 static type is D. If we go to class D, we see, let me just erase or make a new page. Sorry, I'll make a new page first. And then I will erase. So we see that E1 static type is D, and we want to call E1, or EM. So you see in D, is EM defined? No, it's not. So we have to go to its ancestor and see, is it defined as ancestor? Is EM defined in C? No, it's not. And now we're at the top of our hierarchy, so that means that this won't work because it wasn't defined in the class or any of its ancestors. So that means that this method call will not work. But does anyone know what we can do to possibly make this work? Yeah? Exactly, we can typecast. So, as we can see here, so let me just write E1 dot EM. So we can see that EM static type is D, but its dynamic type is E though. So you're right, we can downwards cast to, or let me think. Does anyone know what classes are valid for us to cast into for this to work?
Oh, sorry, Micklin. Just maybe you can put a dot outside,
outside?
the closing parenthesis. Yeah.
There we go. There we go. Does anyone have any idea what classes could we cast to in order for this to possibly work? Exactly, right. Yeah, we can cast to either E or F because the dynamic type of E1 is E, so we can cast down up until E. And if we cast to E, and we call EM, E doesn't have EM defined in it, but you go to its ancestor and you can see EM is defined in F, so it inherits that from its ancestor. So it works for E, and it also works for F. Because F is where EM is defined, so then we're allowed to call EM from class F. And it's also a descendant of its static type. So these are the different things you can do to call it.
Can we cast to C?
You are allowed to cast to C, so let me just write C. If you want to cast to C, so as we can see, C is an ancestor of D. So this cast is compilable. This is an upwards cast. Oh, wait, sorry. So this right here will compile because it's an upwards cast. So when you cast, you can either cast any of its ancestors or descendants. So it will compile because it's an upwards cast. But however, EM is not defined in C. So then it will not compile during the method call because EM is not defined in here. Because when we're casting, we're creating a temporary static
alias
to a static method. So that means right now we're technically giving E1 a static method of C. And when we use method calls, we want to check, is the method defined in its static type? So if we give it C, EM is no longer defined in C or any of its ancestors. So we can't. So like this part is correct. You can cast it, but you just can't call EM on it.
So maybe we can just box that cast expression there. And that one has a static type C, right?
Static type C compiles, but then this right here is where you get not compile. Does anyone know when we do this cast, what methods are we allowed to call? Yeah? Yeah, we can call BM because BM is the method defined in C. So, yeah, that is.
Question. So, which error are you going to get? You're going to get a class cast exception if you have to call EM and you've casted it to C, right? And that is a runtime error, right?
Sorry, say it again. You're saying you're casting E1 to C?
So yeah, so you've done upcasting, right?
Upcasting. Yeah, but that one is not even going to compile, so you cannot execute at the runtime.
It's not class cast exception. He's asking, is that class cast? It isn't class cast exception. It's just like, it's just more like a method call compile error. Yeah, but it isn't a class cast exception. Like, yeah.
Yeah, so class cast exception only happen at the runtime. But runtime can only happen if things compile. But if you actually got E1 cast to C and then call EN on that, it's not even going to compile. So there's no runtime. So there's no class cast exception.
Yeah. So basically, the class cast exception will only happen if things compile. Like if things don't even compile, then you can't even get a class cast exception because that happens at runtime. But like in this right here, this won't even compile. So the class cast exception can never happen because this right here doesn't even compile. Because we're allowed to cast it, we're allowed to cast to C, but just this is saying like we're trying to call a method that isn't defined in C. So EM isn't defined in C, so that's like where the compilation error happens. Does that make more sense? Yeah.
Yeah, so let me just paraphrase what Michelin was trying to say. So here, if you think about that last line over there, overall, you're basically two things. You're doing typecast, and then followed by some method call. So the typecast works because it's an upward cast. However, the method call itself wouldn't compile because after the upward cast, the expression there is going to get a static type of C. However, the static type C is not going to support the EM. So the method call is not going to compile. If it doesn't compile, there's no runtime. If there's no runtime, there's no discussion about what kind of exception you might run into. Right? So remember in the lecture yesterday, we actually talked about like a different categories of the classes, right? Yeah. So whenever you do a typecast, it can either be compile or not compile. And when things compile, you can then think about whether you will get into class cast exception or you don't get it, right? So there's a clear separation between compilation and also runtime. Yeah.
Yeah.
But I think Michelin is going to do more example today. Hopefully that will help as well, right? Mm-hmm.
So yeah, I didn't expect to finish like all the questions that quickly, but there's extra questions, guys. Yay.
Okay, I think, yeah, that's good. So I think Michelin also got a little bit more like an added up question to go over with you guys. And also, if you guys would like to stay, she can also go over maybe some exercises which we didn't really do yesterday in the class. She can also go over them with you for review. But why don't we, it's about 40 minutes. Why don't we take a short break? Okay, I'll pause the recording. We'll take a short break by taking attendance. And then we'll resume after some short break. Yeah.
Okay, so we're going to go over some of the exercises Jackie left for you guys in your lecture yesterday. So was this the first one? Yes. Okay, so here's the first one. So it's kind of talking about class cast exception and compilability, because there's some more exercise on that later for us to do. Yay! Okay, but anyway, so here's our example here of all the phones and everything. So here's the code, and so to first check before anything, let's check, does this compile? So and when we look at if things compile, we look at their static types. So we're looking at this first line over here. Here is the static type, or here's the static type, and I'll do, oh, all right, and then here is the dynamic type. And then we ask ourselves once again, can the dynamic type on the right-hand side fulfill the expectations of the static type on the left-hand side? So as we can see, our static type is smartphone and dynamic type is Samsung. And since it's a descendant, so basically this is saying, is Samsung a descendant of smartphone? Which it is. And any class here will be a descendant of smartphone since it's the superclass. So that means that this line will compile. And then now when we look at this over here, there's two things we got to look at for whether it compiles or not. So first, we always look at the right-hand side. So we're going to look at over here. And we have to ask ourselves, is this cast over here upwards or downwards cast of the static type of my phone? So we look here, my phone is the static type here. Maybe I'll do the grade. So Galaxy S21 Plus is our cast. Where is that here? As we can see that this is a downward cast because the static type is smartphone and we're trying to cast it to Galaxy S21 as a alias static type, so downward cast. And the second thing we've got to look out for now is the left-hand side. So you have to look at this static type over here. Let me do it here. Let me do like this. And we have to ask ourselves the same question that we asked for this line over here. is the right-hand side descendant, or can it fulfill the expectations of the static type on the left-hand side? So Galaxy S21 Plus is a descendant of itself, so this will compile. So yes, this will compile, and then after we check whether something compiles, we have to check, will it run? And that's when we look at dynamic types. So this first line is not where our problem will be. What we're looking out for is a class cast exception, and that happens when there's a cast. So that means we're gonna have to pay really good attention to this over here. So there'll be no class cast exception if the dynamic type of my phone, so the dynamic type of my phone, which is Samsung, can fulfill the expectations of the cast, which is Galaxy S21 Plus, which basically means that when you're casting something here, the cast should be an ancestor of my phone's dynamic type. So as we can see, when we look at this, here's Samsung, its dynamic type is Samsung. For it to get no class cast exception, Galaxy S21 Plus should be able to fill the expectations of Samsung. But as you can see, since the descendant, it's not, because when you have a descendant, it should have more expectations. So since there's more expectations, or there usually is more expectations in Galaxy S21 Plus, it can't fulfill the expectations of Samsung because it has more. So that means that this will cause a class cast exception. So this all compiles. Like when you do it, it compiles, nothing, no compilation error, no 30% off your test, but you get a class cast exception. So, and yeah, that's why. So basically, what can be valid if you want to cast can only be the ancestors of Samsung. So that would either be Android or smartphone would be valid casting to my phone. But you wouldn't really cast a smartphone because its static type is already smartphone. But you could. So yeah, does that make sense? I know you guys just learned this yesterday. So, oh, like want me to go over the whole thing again or a specific part?
Okay, so my phone's dynamic type is Samsung, right?
So this is dynamic type.
And
You're trying to cast it to Galaxy S21 Plus.
okay, when you do casting, you're changing the static type of my phone, right?
Yeah, you're like temporary like aliasing a static type, a new static type.
Okay, yeah, pretty much right. But to be more precise, the my phone static type never changes. So maybe Michelin can maybe visualize that a little bit, right?
Oh,
so
yes.
after executing that line, so my phone is really pointing to the new, like a Samsung objects, right? Yeah, just wait for, yeah. So that means it's one name, my phone over here, pointing to that object here. So we can also make a note, static type is a smartphone, okay? So the principle is very clear. The static type, once declared, never changes, never, ever. So now, if we try to look at a typecast, when we say we are trying to cast my phone into Galaxy S21 Plus, we are not modifying my phone itself. We are creating some alias of a different static type. So what we're doing is, maybe Michelin can draw some alias over there, maybe some arrow, oh, you did, okay. That alias over there is of a different static type, which is the cast type, Galaxy S21 Plus. So you can see the two references over here, my phone and also the alias. They are pointing to the same objects. But in order for the typecast to really be class cast exception free at the runtime, you got to make sure the dynamic type of the object can fulfill the expectation of the cast type. So meaning that you got to check to see whether Samsung is a descendant class of Galaxy S21 Plus. And as Michelin showed earlier, so in this case, Samsung is not a descendant class of the cast type. So you're going to run into class cast exception. Still no? Which part? Are you confused?
Okay, so the static type doesn't change when you cast.
The static type doesn't change, that's correct.
You're changing the dynamic type, right?
We are, okay, for this typecast specifically, right?
Yeah.
We are not changing anything here. We are just creating something new. Not really a new object, we're creating a new reference. We're creating like a new copy of the address.
Okay.
So you can think about the first arrow we have, my phone pointing to the object over there of type Samsung, right? That's the first one, right? And then when we try to do the typecast, we are not modifying the object there. We are creating some copy of its address. It's like alias, right? But that copy of the address has a different static type, which corresponds to the cast type, which is the Galaxy S21 Plus. Okay? However, this typecast will only work at the runtime if the actual dynamic type can fulfill its expectation. So we are basically asking if the dynamic type Samsung can fulfill the expectation of Galaxy S21 Plus, which it doesn't, right? Yeah, but Michelin, I think there's another example, right, for this. Okay, she will do it again. Okay, but I think just a quick recap for everybody. Every time you're looking at a typecast, right? First of all, think about whether the typecast is going to compile. It will compile if it's either an upward cast or downward cast, right? Compilation. If it compiles, you're going to execute a typecast. When you get to the runtime, the concern will be, are we going to run into class cast exception? In that case, you got to look at if the dynamic type of the objects can fulfill the expectation of the cast type.
Kind of look at this.
Oh yeah, why don't you go over that?
Yeah.
Yeah.
Oh, okay. So I guess we'll go over this now. Yeah, so in this example, we're looking at Android as a static type. So I'll just Android, and the dynamic type is Samsung. So Samsung. So then we're talking about a lot going on here. Compiled cast is in green. Okay, yeah. So we're talking about compilable cast. Compilable cast has to be either ancestors or descendants of the context object static type. So maybe I shouldn't fully, maybe I'll do like.
So basically, since we already got the diagram is quite messy already. That's my fault, right? It's already there. So why don't you use laser pointer?
Okay.
Might be a little bit easier for you.
Yeah.
Okay.
So the static type is Android and dynamic type is Samsung. So we're talking about compilable cast. So that means it has to be an ancestor or descendant of the context object, which is, we're talking in this case, my phone, static type. So static type is Android. So that's why when we look at that's why everything in green here, so all of these here are descendants of Android, and the only ancestor of Android is smartphone. So that's why these are all compilable. So these will compile, so it just compiles. So on the same page. Okay. And then now we're talking about non-compilable casts. So non-compilable casts are basically if it's not its ancestor or descendant. So that's why basically just these three, because these three are not ancestors or descendants of Android. But then now we talk about class cast exception. So as we were saying, in order for you to not get a class cast exception, that's in red. Yeah, so exception free cast, it has to be an ancestor of the context object's dynamic type. So that's why now we're looking at Samsung. So that's why you can see in the blue here, all of these three will not give you a class cast exception because Samsung can fulfill Android and smartphones expectations. So, because like anything that Android and smartphone can do, Samsung can do it as well because it will inherit that. So that's why you don't get a class cast exception. But if you do, as like we were doing earlier, Galaxy S21 or Plus or Galaxy S21, you will get a class cast exception because these are descendants of it. So these can't fulfill the expectations of the dynamic type. So that's just for these two, but also just like these.
Sorry, Michelin, if you don't mind. So, excuse me. Let's say we are trying to cast the Galaxy S21. So this will run into class cast exception because the dynamic type, Samsung, cannot fulfill Galaxy S21 expectation, right? Yeah.
Yeah. And if you look at like, I don't know how to say this name, Huawei?
Huawei?
If you look at all like the Huawei phones here, like these are not ancestors of the dynamic type. They're descendants of like the static type, but when we're looking at class cast exception, we're only looking at dynamic type. So yeah, so these aren't ancestors of the dynamic type, so that's why you get a class cast exception. So yeah, it's a lot to take in. You might, yeah.
So possibly, we can also repeat again, that's okay, but maybe also try to maybe look at only this part of the lecture from yesterday. That can also help, when I try to develop them from scratch. So scratch. So just remember every time, again, you talk about any typecast, there are 2 stages over here. Number 1, there's a compile. You will compile if it's either upward cast or downward cast. If there's neither, it doesn't compile. Okay? And then if that compiles, you're gonna go to the second stage, which is about runtime. At the runtime, it's either you get class cast exception or you don't get it. You will only get the class cast exception if the dynamic type cannot fulfill the expectation of the cast type. Okay?
Yeah, so when you're looking at like compiles, you were only looking at static type. So we're only looking at static type. We're talking about whether it compiles or not. But when we're looking at class cast exceptions, we're only looking at the dynamic type. So the static type doesn't matter. We're only looking at the dynamic type. So just compile, look at static type. For class cast exception, look at dynamic type. So,
yeah. If there's a particular part you're gonna get stuck, let us know. We can solve it right away.
So so now going back to, we're just going to do one more example on the, whoopsie, just erase that. Okay. So now we're doing this example here, similar to the last, but so we're going to look at this over here, and first we got to check, does it compile? And once again, we look at whether it compiles, we look at the static type. So once again, we have the static type of my phone is smartphone again. And the dynamic type is Samsung. Oh, so it's the same thing, Samsung again. And so you have to ask yourself, can the dynamic type fulfill the expectations of the static type, which is smartphone? And once again, it can, because since it's a descendant of smartphone, that means it inherits everything that it can do, which is why it can fulfill smartphone's expectations. And so this one compiles, just do a little check mark, a happy face. And now we have to look at whether this compiles. And when we have casting in a line, there's always like 2 phases of looking at compilability. You have to look at the right side first, whether the cast will compile, and then you look at the left-hand side, whether it's, we'll get there. But first step first, you have to look at, will this cast compile over here? So we're looking at whether iPhone 13 Pro cast will work. We have to ask ourselves, is the static type of my phone, which is smartphone, fulfill the expectations of, I'm wrong, sorry. It has to be upwards or downwards, scratch that, it has to be upwards or downwards. So I'll just highlight iPhone 13 Pro here. Yeah, so when we're looking at whether this cast will compile, we look over here. So you have to look, is this an upwards or downwards cast of my phone static type? So yeah, so we look at my phone static type is smartphone. And you have to see, is iPhone 13 Pro an ancestor or descendant of it? So as we can see, if we go boom, boom, it's a descendant. So that means it compiles on this side at least. So we're good for now. And then now when we look at this side, we have to check, now we check here. Is this cast over here a descendant, or can it fulfill the expectations of the static type on the left-hand side? So that's where we ask ourselves kind of a similar question over here. But since, once again, this is iPhone 13 Pro as well. Where's iPhone 13 Pro? Here. So this is the same thing, it's obviously going to compile. But yeah, so that means right now we know it's going to compile. We know it compiles at least. And now we have to ask ourselves, are we going to get a class cast exception? So that's only going to happen when we have our casting. So we don't need to look at this first line over here. We're going to look at right over here. So once again, now that we're looking at class cast exception, maybe I'll draw it out, yes. So we have, maybe I'll draw it a bit bigger. Samsung, my phone, and its static type, smartphone. And now, where's that? Oh yeah, so now when we're checking whether a class cast exception occurs, so basically that means we're creating an alias static type of iPhone 13, okay. 13, we'll just pro. I don't want to write the whole thing, but that's, yeah. So we're kind of creating an alias over here. But then we have to ask ourselves, is this correct? So you have to ask ourselves, can the cast fulfill the expectations of the dynamic type of my phone? So that's like
The opposite. Can the dynamic type for my phone
yes,
fulfill
the
cast type?
expectations
Right?
of yeah. So can the expectations of my phone fulfill the expectations of iPhone 13 Pro? Yeah.
That's good.
So once
Well,
again,
guys may be thinking this way, right? I think Michelin said it correctly, but if you look at the arrow there, so you can see Michelin was trying to draw the green one. So iPhone 13 Pro is the static type for the typecast, right? That one is supposed to point to the objects of type Samsung, right? You basically want to ask, can the object itself fulfill the alias static type? So can Samsung fulfill iPhone 13 Pro? It will only fulfill if Samsung is a descendant class of iPhone 13 Pro. Apparently it is not. So class cast exception. Okay.
yeah, so once again, as we were saying, in order for you to not get a class cast exception, the cast has to be an ancestor of the dynamic type. Yeah, so that means once again, it can either be Android or smartphone, because if it was a smartphone or Android, then Samsung can do whatever an Android and a smartphone does. But if we're talking about iPhone 13 Pro, a Samsung can't do what an iPhone 13 Pro does. So that's why you get a class cast exception, because they don't it doesn't fulfill the expectations. So that's why it get a class cast exception. So
Is it getting better for you? From better? Okay. Yeah.
yeah, so when you compile, just always look at static types. But the important thing is that when you look at class cast exception, you have to look at this dynamic type. I think that's the main important thing. You have to look at this dynamic type and compare it to the cast.
Can you explain the aliasing again? The professor mentioned that when you do the casting, nothing gets changed. Not the dynamic type, not the static type. But aliasing happens. So can you just, on the diagram, show the aliasing? When you're doing aliasing, you call it my phone again, and then you place the static type as iPhone 13, and then you point it to the Samsung object? Or what do you actually do? When you're drawing it, when you're tracing, you see you created the Samsung object,
Yeah.
right? The actual type being Samsung, the dynamic type, and that was for the my phone, right?
Yeah.
So when now you reach the line for iPhone 13, so IP, so you know, okay, IP static type is iPhone 13 Pro, right? And then you do casting. So when you do casting, you're saying that, okay, you're not changing the dynamic type and you're not changing the static type, but you're doing it's like a alias, right? How do you just write iPhone 13 Pro and then you just point it to the object of Samsung, and that's just how you trace it? Or is there a specific way of tracing it so that you don't get confused? You get what I'm saying?
Hopefully this answers because the point of doing this is because now you're assigning this variable IP to this cast now. So that means iPhone 13 Pro is now the dynamic type of IP.
It's okay.
Is it?
Don't worry, no, it's okay. Let me help a little bit. Okay. So first of all, we are okay to know that these two lines compiles. Okay. If that compiles, so compilation, we are passed. Let's go to runtime. So what Michelin draw was this line here. If you execute it, you're going to get my phone pointing to some Samsung objects. Okay, good. And then what about executing this line? In order to execute this variable reassignment, we have to first of all execute this part over here. And this part over here is a typecast. And that one there is not going to modify this object here. Also, it's not going to modify my phone in any way. We are basically creating a new alias corresponding to this typecast, which is our definition for typecast, right? Good. And then when we are trying to create this alias over here, is this alias creation gonna be successful? If it is successful, we create an alias. If it is not successful, we got class cast exception. So maybe I can think about conceptually also put a question mark over here. Is this going to be successful? It will only be successful if the actual dynamic type over here can fulfill its expectation? Can Samsung fulfill iPhone 13 Pro expectation? Samsung can it fulfill iPhone 13 Pro? It cannot, because this is not a descending class of that. So this alias over here that corresponds to the typecast is going to fail. And the way we call this failure is class cast exception. Right? So it's going to cause the class cast exception.
But I think that's like, what's like the point of this? Like, why are we even doing it if it does nothing?
Yeah, because like, I was getting confused at first because I was thinking, okay, if you're doing aliasing, what do you name it? You just name it iPhone 13 Pro when you're actually drawing it? Or do you name it like, do you name it my phone?
I see what you mean.
Professor just said that my phone doesn't change the static type or the dynamic type doesn't change, so you cannot name it my phone. So you have to name it something else.
Yeah, okay. So here, this is the name of the reference variable. That's why we got my phone here pointing to here. Yeah. That one we are good. Okay. Whenever you're doing a typecast, remember in our slide we said it's going to create an anonymous alias. It's basically an alias without a name. So you can think about iPhone 13 Pro here, it's not a name. It's basically just the static type you can think about, right? It's a static type. So we are trying to create an alias over here without a name that has the static type, iPhone 13 Pro. Yeah, is this alias creation going to be successful? It will only be successful if Samsung can fulfill the intended static type of this alias, which is iPhone 13 Pro. It cannot. So that's why we're going to get a class cast exception. Yeah, maybe your confusion was, is this really the name of the alias? No, it has no name because we're doing a typecast. Typecast does not create any name. The only way to get a name for this alias over here is by using this variable assignment, in which case IP is actually going to point to this object as well. So we got different references. That's something also we said about in the lecture for the typecast. Yeah.
Thank you.
Okay, keep going.
Okay, so, okay, there are two questions. You can go first.
Sure. One question. How can we change one object's dynamic status other than typecasting? Is there any other ways?
Sorry, can you say the question again?
So how can we change a dynamic status of, so dynamic type of an object other than using typecasting?
How can we change the dynamic type of an object other than typecasting? Okay, so I'll answer quickly. Okay, so when you do a typecasting, you are not changing anything, right? Okay, so yeah, guys, please shoot out the question, right? That's exactly what the review session is for you guys. Okay, so let's say here, if you're doing this over here, right? This is a typecast. So for the typecast, we are not really modifying anything. We are not changing Samsung objects. We are also not changing anything about the my phone. Not really. We are creating something. Okay, and the alias we're creating has certain static type that's intended. Intended in the sense that it may not succeed. If it doesn't succeed, we got class cast exception. The only way you can change the dynamic type of some object is by saying, so let's say I got some reference variable v, has some static type, has some dynamic type, sorry. If I want to modify its dynamic type, I can only reassign that to something else. In that way, I can reassign its dynamic type. But it's a different discussion, right? So again, recap, whenever you're doing a typecast, you're not really modifying anything. You're just trying to create an alias of certain static type that correspond to the cast type, which may succeed or may fail. So in which case, you got to determine if the dynamic type over here right now can fulfill the intended static type, right? Good. There we go.
Any other questions? Okay, so yeah, so we did a little bit of that. So now I'm gonna give some extra practice for these questions now. So just a little quick reminder, this is what our hierarchy looks like, or I'm just gonna make a new page.
Oh, Michelin, just before you continue, let me just pause the recording, just make sure it's okay. Yeah, guys, we'll definitely continue. Okay, I'll just go here. Okay, so when you talk about typecast, right? Of course, what you learned back in the first year, or before we learned about inheritance, for example, if you got, for example, double, let's say D equals maybe 23.5. I think that's an example Judy also gave, when she did the written test review, written test 1 review session. So integer, let's say I equals, if I simply say D, it's not going to compile because D here contains some fractional part, which will be too much for an integer, which does not have any fractional part, right? So the way to get around with it is to say integer I equals, and we're trying to cast D into integer. So this typecast over here is not trying to create any alias. There's no alias here. There's no reference. It's primitive, right? So this one here only try to truncate the fractional part of the double, right? So the result will be I over here being an integer box is going to store, rather than 23.5, it's going to store just 23. Okay, that's for primitive, right? It's also called cast, but has nothing to do with what we're talking about right now. What we're talking about is we talk about reference type, and also there is some inheritance hierarchy in the context. That's a different issue, right? But I'll write it down just for completion. It's actually a very important question. So, so this part here is about primitive. And then we also talk about reference type. Okay. And the more precise way to say that would be reference type plus some inheritance. Because if you only got reference type, let's say person, but you don't have any inheritance hierarchy in the context, you cannot do typecast, right? So this one here, so let's say if you got any reference variable, let's say, or to make it a little more general. So you have some type C1 over here, and also you got some variable V, okay? So now, if you are trying to do a typecast like this, right? Let's just review very quickly, right? So number one, for compilation, you only look at the static type. You want to look at the static type of V, right? The variable being cast into, right? You can think about conceptually, V is now pointing to some object over here, has certain dynamic type. Let's call that C2, okay? And then V has the static type, which is maybe, I don't know, let's say T over here. Okay, so you can see we got 3 types in the context over here. We got cast type, we got the static type, also got dynamic type. 3 types over here, right? So whether or not it was going to compile, it's going to be either upward cast or downward cast. We want to see whether whether C1 here is an ancestor or descendants of T. If C1 is an ancestor of T, it's an upward cast. If C1 is a descendant of T, it's a downward cast, right? Already done. Static type of V, which is T. It would be upward cast if C1 is ancestor of T. It will be downward cast if that's descendants, right? Okay, that's about compilation, okay? And the second phase will be runtime. And the runtime is really about creating that alias over here, right? We don't modify anything, as Tommy just asked, right? We don't really modify anything. So this one here, we are creating some alias that's going to be of intended static type C1. All right, so now the question is, can the dynamic type C2 fulfill C1? All right, so the question is, can the dynamic type C2 fulfill the cast type C1?
C2 has to be a descendant of C1.
Yes, in that way, of course, you can always think about expectation first, whether one thing is going to fulfill the other. It'll be a little bit easier for you to derive the sentence afterwards. Since we're asking whether C2 can fulfill C1, we're asking whether C2 is a descendant class of C1, and then you can check the inheritance hierarchy that's in the context, right? Mm-hmm. Right, okay, it's a good question here. So recap, whenever we talk about typecast, of course, there are 2 possibilities. You got to look at the types of the variable. If you're talking about primitive type, then all you're doing is you're truncating some information. Nothing to do with something like a class cast exception, nothing, right? But here, when you talk about reference type together with some inheritance, then of course it's going to be more complicated, right? Compilation, either upward or downward. If neither upward nor downward, in that case, you're going to have some compilation error for the typecast. And then if the typecast compiles, you're going to look at whether dynamic type can fulfill the cast type. If yes, no class cast exception. If it doesn't fulfill, then of course you got class cast exception. Yeah. Go back. Okay.
Okay, so going back to some exercises I made that we can do some extra ones. So assuming like everything that compiled from before and we're just continuing on. So
Mingling, how about just highlight the ones that already compiled so people can see a little bit clearly. Yeah. Good.
There.
Thank you.
So earlier we did D2 equals E1, but now what if we wanted to do E1 equals D2? So we're flipping it around now. So I'll just start explaining it. So yeah, so once again, whenever we're doing variable assignment, we always have to look at the static type of the right-hand side and see if it's a descendant or if it can fill the expectations of the static type on the left-hand side. So we look at D2. D2 static type, D2 static type is C. So that's C. Honestly, we can like just delete this now and move all of this up. And now we look at E1's dynamic type. So E1's dynamic type is D. So now when we look at this here.
Nicolin, sorry, E1's static type.
Yeah, sorry, static type is D. So now we have to ask ourselves, can the static type of D fulfill the expectations of the static type of E1? Which it cannot, because E1 is not a descendant of D. So this will not compile. But if we notice, D2 and E1 are both already pointing at the same thing. So does that mean anything? Or any guesses?
So what Michelin was asking, basically, let me rephrase, it's a good question here. So guys, if you look at the diagram right now, you can see D2 and E1, they're basically pointing to the same objects. That means their dynamic types are both E. Can we do E1 equals D2, given that they're just the same objects? Can we just assign them to each other? You're basically just reassigning to the same objects. Can we do that? How come?
Because at compilation time, the static types, the static type for E1 is D, right? And the static type for D2
Right.
is C.
Yeah.
And basically, C cannot fulfill the expectations of
D. Yeah.
Therefore,
Mhm.
it won't compile.
Yeah, exactly. So basically what we are trying to express over here is, doesn't really matter what the dynamic type is. Even in the extreme case, you actually got two references pointing to the same objects. Doesn't really matter, because at the compilation time, if you want to determine if variable assignment is going to compile, you only look at the static type. Okay, that's really the point.
Yeah, so even though like it might look like this worked because E1 and D2 now both point to the same thing, it didn't work. It got compilation error. So that was like the main point of that. So this kind of goes to show that even though you can do D2 equals E1, you can't always do the other way around. You have to make sure that the same rule about the static applies. So yeah, that was one example. Another example is pretend we created.
Oh, Michelin, maybe put a cross mark just
Yeah.
to be more explicit.
Wrong.
Thank you.
Not trot. Okay. And then if we do F F2 equals new F, and then we do F2 dot BM and F2 dot EM. So now when we have this over here, we first have to ask ourselves, will this compile? So will the right-hand side dynamic type fulfill the expectations of the left-hand side static type? And yes, it will, since they're both F in this case. And since we have the new keyword here, that means we're going to create a new object. So we're going to draw F2 static type, or is F as well. So, and if we look at, when we look at these method calls, you have to ask ourselves, are these methods defined in F2 static type? So F2 static type is F, and we can see that BM and EM are both defined. So these will compile, and I'll just print F.BM and F.EM. But that was not the question. It's not that easy, guys. I'm going to add a little bit more now. But what if now we cast, let me make this a little bit neater. So now we are.
Oh, Michelin, how about this? How many do you have? Is it like a 2 or 3, or?
I have 3 more.
Why don't you add all the 3 over here, and then we can let people maybe give them pause a little bit. They can give it a try, and then we can go over. That might be a little bit better.
Okay.
How about label them 1, 2, and 3?
1, 2.
Yeah,
3.
and also zoom out a little bit so people can also see the inheritance hierarchy.
Oh, yes, yes. There we go.
So guys, why don't you take maybe 1 minute or 2? Okay, so Michelin actually just added 3 additional exercises over here, 1, 2, and 3. Think about them independently, in isolation for each one of them. So for each one of them, basically 2 questions. Number 1, does it compile? Number 2, if it compiles, do you have runtime class cast exception? Okay, yeah, take a minute, maybe take 2 minutes, and then Michelin will go over the answer with you. Okay. Okay, just another moment, and then we'll go over the answer.
Okay, so hopefully you guys have an answer by now. We're gonna go one at a time. So for the first one, there's two parts to it. We first have to look whether this cast is compilable, and then we have to see, is this method call here compilable? So what we do first is we have to see, is this a valid cast? And for something to be a valid cast, it either has to be an upwards or downwards cast of the static type of the context object. So our context object, F2, static type is, I should create a new page. Page. And then I'll just erase this. Okay, so here's our static type is F, and our dynamic type is F. Yeah, so we look at this, we have to say, is this an ancestor or descendant of F2 static type, which is F? So we look at F here, and we can see that C is indeed an ancestor of F, so therefore that this cast now compiles. But now when we look at this, we have to look at this as now, draw a little box. This is now seen as static type, now C. So now when we're looking at this method call, we have to see, is this method call now defined in the static type of not just F2, but now C. Since we have the casting here, we have to look at the static type as C. So now we look at our class D here, and we see that BM is indeed defined. So that means that this will compile. But now, does anyone want to tell me what will this print out though? Yeah? Yeah, see, it's a good try, but yeah, so a mistake is to think that it is C, since we did cast it to C, but however, that just affects the static type. F2's dynamic type is still, however, F. So, and when we're looking at method calls, that's when we have to look at dynamic type. So when we look here, so now we can kind of think that like our new static type is now C, but the dynamic type is still F. So then we have to go to when we do method calls, we go to our dynamic type, and we look at the class itself, and we see if the method is defined. So we see that BM is defined here. So then we're still calling F's version of BM. So it's going to be, still F dot BM.
Yeah, so what Michelin is showing here is something what we learned in the class called dynamic binding, right? So after you pass the compilation stage, if you want to see which version of the method is being called, you have to look at what's the object that's being pointed to at the moment. What's its type, right? Dynamic type. Mm-hmm.
So yeah, so just be careful. When you do a cast type, it doesn't change the dynamic type of it only changes the static type of what the context object is. So now looking at question 2 now, we first have to check, does this compile? So once again, we already determined that this is a valid cast. So its static type is still C. And then when we look at whether a method call is valid, we have to look at whether this method is defined in this static type's class or whether it has been inherited from any of its ancestors. So if we go to C, we see that EM isn't here. And since EM is its superclass, we can't go to any of its ancestors anymore. So therefore, the method's not defined. So we'll get it does not compile. Does not compile. So once again, this cast perfectly compiles fine. It's just that when you do this method call, that's where you get the compilation error, because EM is not in C. And now finally, we have this example here. So we have just an additional cast here. So we already saw from before that however, when we do like multiple casts, you always have to work like inside out. So you're not going to do the A first, you're going to apply the C first, because since it's like the closest to F2. So as you already saw before, this will make this static type this is a valid cast, and its static type will now be C. Sorry, I think let me just move it down a bit so we can all see it a little bit better. So this static type is now C, but now we still have one more cast to A. So now when we first want to ask ourselves, does this compile? And that's when we have to look at whether A is a descendant or ancestor of C. So it's kind of a common mistake to think that the static type of F2, which would be F, but we're looking at the static type of C, since this cast casted it to C. So as we can see that A, I'll do it in orange. A is a descendant of C, so this is a valid cast. But however, if some people want to make the mistake to think that this still has a static type of F, and you might think like A is not a descendant or ancestor of F, so that won't compile. But we're not looking at F2's original static type. Since we casted it to C, it's important to make sure you're looking at the new static type. Mm-hmm. So therefore, this will compile. Yeah?
Good question. So which methods is that able to call the file?
A?
Yeah, like the whole thing. Like which method?
Oh, this whole thing?
Yeah.
This whole thing would be able to call. Oh, you get the.
Yeah,
like,
so
yeah.
Okay, how about this? Let's delay this question here. We'll definitely answer that. Maybe Miklim, she will finish the discussion for this one first, and then we'll talk about method call. Okay. How about we finish this one first? Yeah.
Yeah?
If you want to call any method, you can't call EM or EM from because they are not coordinating.
Yeah, we'll get to method call in just one moment. Yeah, let's finish this discussion. We'll definitely revisit that. Yeah, just to not get distracted. So
this is compilable. However, there is going to be a class cast exception because the dynamic type of F2 is still F. And when we're looking at class cast exception, we always have to think whatever we're casting to has to be an ancestor of F2. So earlier I was saying it was wrong to still look at F for like casting to A, but you have to look at the dynamic type F when you're thinking of the original dynamic type when you're looking at a class cast exception, because A is not an ancestor of the dynamic type, so therefore this would give you a class cast exception. So it compiles because we cast it to C and then we cast it back down to A, so it's perfectly fine. It compiles. However, you get class cast exception because the dynamic type is F. So A is not an ancestor of the dynamic type. Mm-hmm. So did that make sense? Mm-hmm. But yeah, but back to the questions, like since we get class cast exception, like we can't call any methods, even if like we did call a valid method that just A can call, since we got the exception thrown, it would just stop there. Mm-hmm. But in general, just class A, the methods that A can call are BM, because every class, every descendant of the superclass inherits whatever is in the superclass. So since BM is defined in C, B can call BM and A can call BM. So they all inherit it. So if we just had like a new object like A1 equals a new A, we could like totally be fine to do A1.BM. So I think, does that answer like the method call questions?
Yeah, so maybe you can put another label called number 4 and then write out the expression there. So basically you got a original cast from 3 and then how do you make a method call from there?
Wait, pardon? Wait, what?
Okay, no worries. This one, yeah. Let me just help go a little bit here, okay? So, yeah. So here, number 4 is good. So this cast over here, so let's do that. This is basically what we discussed in class yesterday, right? Okay, good. So let's build something a little bit additional, okay? This is a typecast. And this particular cast over here has the static type A. Upcast to C, downcast to A. And then this whole thing over here, we can say another parenthesis over here and dot. What can we put over here, right? So now we can put anything that's expected on A. As Michelin said, the only thing you can put will be BM. Okay?
But wouldn't you get class cast exception? So you can't.
Compilation.
Oh, okay.
Yeah. So compilation-wise, of course, you can put you can only put BM. So it's going to compile. However, when you try to execute this line here, you're going to run into class cast exception when you're trying to downcast to A, right? So let me just recap very quickly. So this one here, dot BM, is going to compile. Why? Number one, from this particular part here, it's an upward cast. And then this has a static type C. And then casting from C down to A is a downward cast. So cast is okay. And then, since this typecast has static type A, can you say A dot BN? Yes, you can, because BN is declared in A. Compilation-wise, we're good. Now, what about runtime? When you do runtime, as Michelin said, you're going to do inside out. When you do this particular typecast over here, can the dynamic type of F2 fulfill C? Yes, it can, because you can see that F2, dynamic type F. Can F fulfill C? Yes, indeed. However, can F fulfill A? No, it cannot. So when you try to do this second downcast over here, you're going to run into class cast exception. So even though it compiles, but at the runtime, you are going to run into the class cast exception right away before you can even get to the method call. Right? And you recall the earlier lecture, if you got some exception, the execution flow is going to be disrupted. So you don't even get a chance to execute BM. Right?
I think that's it. Yeah. Is that it?
Okay, any other questions? All right, guys, thank you so much. And then, yeah, we're going to release the recording a little bit later. Okay, and then, yeah, thank you so much.
Good luck on your test, guys.